Hi everyone, so today we're focusing on the very beginning of our Algebra 2 textbook. We are in section 1.1 and this is going to be the first half of section 1.1 in tonight's lecture video. This is one of the videos that you're going to have to definitely be pausing things, rewriting things, going back, watching it a second time. Here we're really getting into the nitty-gritty in the textbook, so make sure that you have your printed guided note sheet so that you can follow along with the lecture. And just as a reminder, you should be writing down pretty much everything that I'm writing down. You should be taking some time to think about the problems, to understand them, jot down any questions you may have. This is really an interactive experience for you, so come to class prepared with lots of questions and all of your notes. Okay? So as we move into section 1.1, just a few warm-up exercises. First, we're going to find the x and y intercept for our first two functions. Now, if you think about our notes from last class, the x-intercept is when y is equal to 0, and the y-intercept is when x is equal to 0. So we can go right ahead and plug in those values and see what we get. So first, I'm going to substitute y for 0. And that's just because it's the second term in my equation, so I feel like it's easier to get rid of. 5 times 0 is 0, so I just delete it. And I say 3x is equal to 15. 3 times x equals 15, so 3 divided by 3, 15 divided by 3 is x equals 5. So when y is equal to 0, x is equal to 5, and so that tells me my x-intercept is 5. The second part of this problem is to find the y-intercept. So I'm going to need to plug in 0 for my x. So 3x minus 5y equals 15. Plug in the 0 for my x. 3 times 0 is 0. So I just have negative 5y equals 15. Negative 5 times y, so I'm going to divide by negative 5. Divide by negative 5. Y equals negative 3. And so my y-intercept is negative 3. Go ahead and do number 2 on your own. If you need to pause, please do. But again, when y equals 0, you have the x-intercept. When x equals 0, you have the y-intercept. The only trick I would say is make sure you go back to the original function whenever you do the second value. Don't try to substitute into what you've solved already. It's not going to work for you, okay? So go ahead and solve that. And I will help you out with problem number 3. Problem number 3 says a ball is thrown, so its height, h, in feet, is given by the equation h equals negative 16t squared plus 10t, where t is the time in seconds. What is the height when t is 1/4 second? This is just a substitution problem, right? I'm just going to take this equation here, and it says what's the height when t is 1/4? So I'm already solving for h, which I'm assuming is height. So all I need to do is plug in what would be the 1/4. So anywhere there's a t, I would plug in 1/4. As a note here, I've got negative 16 times 1/4 squared. That exponent is only applying to the 1/4. It's not applying to the whole negative 16 times 1/4. If it was, you would have more parentheses or brackets here, but since we don't, I'm just applying it to the 1/4. So how do I square 1/4? Well, 1/4 times 1/4 is the same as 1 times 1 is 1, over 4 times 4 is 16. So now I have negative 16 times 1/16. Hopefully you take a look at this and you recognize, well, if negative 16 over 1 times 1 over 16, this is just going to equal negative 1. Plus 10 times 1/4 is 10 divided by 4, really, which would be 2.5 or 2.5. So negative 1 plus 2.5 is 1.5, or 3/2. So the height when I'm jumping off of when the ball is thrown in the air, after 1/4 of a second, it's 1.5 feet high in the air. Okay. Note that when I'm doing the multiplication, it gave me a fraction. So instead of saying 2.5 here, I did use 2.5 because it started with a fraction, and so I continued with a fraction. You can always also use improper fractions like I did in the solution. I said it was 3/2 instead of 1 1/2. It's more mathematically correct, but it's a personal preference for you. By the way, if you went and you did problem number 2 for yourself, I got a y-intercept of 7 and an x-intercept of -3.5. So you might want to check your answers if you didn't get the same work as I did. Moving on to some vocabulary. We're going to start with the x and y intercept. I'm just going to check those off right away because we know those and they're in our notes from last class, from 2 classes ago. My apologies. The quadratic equation. The quadratic equation is y equals ax squared plus bx plus c. A, b, and c are your constants, or your values, your coefficients, right? And obviously your x and y are your coordinate points. So when we're thinking about this function, the only rule here is that a cannot equal 0. So what that tells us is that this is not a linear function, right? A linear function would be y equals mx plus b, or y equals bx plus c. Without the a, we don't have a quadratic function, so we need to have either a positive or a negative value of a. The axis of symmetry divides our parabola. So again, a quadratic function is not linear. It's what's called a parabola. And the parabola looks like a U or an N. And the axis of symmetry divides the parabola evenly in half vertically, right? It reflects that parabola from either side. The vertex is either the highest or lowest point on the parabola. So in my quick drawings, my vertex could be the lowest point of the parabola or the highest point of the parabola, but depending on which direction it's facing. So how do I know which direction it's facing? The parabola will have a minimum point if the vertex is y coordinate, sorry, 2 O's, will be a minimum when a is greater than 0. So in my equation, if a is positive, I'm going to have a minimum point and my parabola is going to look like this. It's going to scoop upwards. If my parabola, my vertex on my y coordinate has an a that is less than 0, or it's a negative a, my parabola is going to scoop downwards and it's going to have a maximum point, right? So minimum, a is positive, maximum, a is negative. You'll definitely be able to refer to these notes because I know that this is a lot to remember right off the bat. Example number 1. When I'm looking at my problems here, this is actually on the back of your worksheet just in case you're following along. Graph y equals 2x squared and compare the graph with y equals x squared. Well, I have the graph y equals x squared right on my little grid here. It was the blue one. And I have the graph y equals 2x squared. The only thing that you really want to do when you're thinking about graphing in this basic form is creating a table for yourself. So I think I have a blank table on your worksheet. And the way that we're going to fill that out is we're just going to say y equals 2x squared. And we're going to start substituting x values. I tend to start with 0. When x is 0, what is y? So in this case, 2 times 0 squared is 0. So y equals 0. So when x is 0, y is 0, right? And then I start substituting more numbers. So if y equals 2 times x when x is 1 squared, 1 squared is 1, so 2 times 1 is 2. So when x equals 1, y equals 2. I'm literally just picking numbers and plugging them in. Once I have a few values in the positive direction, you're going to want to go back and find a few values in the negative direction. So if I have a negative 1 for x, my y value is 2. If I have a negative 2 for x, my y value is 8. Right? If I have a positive 2 for x, my y value is positive 8. You might want to go through and check a couple of those coordinates. You don't have to. The question also asks you to compare this graph, y equals 2x squared, to the standard parabola, which is y equals x squared. If you look specifically, the y equals 2x squared is a little narrower than y equals x squared, and at some point we'll talk about why that is and how that happens. But just to kind of give you a sense of what we're doing here, we're just plugging in those examples for our numbers. Example number 2, graph y equals negative 1/2 x squared plus 3. Compare the graph with, again, our standard parabola y equals x squared. I have my data here for you, but I'd like to see your work. So go ahead and take a minute, pause, and go through that problem for me. Again, you're just substituting x values. So y equals negative 1/2 times x squared plus 3. Plug in a value for x. It could be 0, it could be 1, it could be 2. Solve for y, and look at those coordinate points. You're also going to want to plot those specific points, right? You're actually drawing these graphs on your paper. So if I plugged in 0 for my x, and I solved for when x is 0, y equals 3, I need to plot that point. When x is 0, y equals 3. There's the first point of my graph. Then I continue. Be sure you have all those steps. Some key concepts. We're flipping back to the front of your page for your notes. When you're thinking about the properties of a graph y equals ax squared plus bx plus c, there are those few things that we were looking at in terms of our vocabulary. So we've got 2 images on your paper. The first has our opening upwards, and the second has our opening downwards. Remember, when you open up, then a is greater than 0. When you open down, a is less than 0. Something else that is interesting to know is that the vertex point, when you're looking at the x value for your vertex, x is equal to negative b over 2a. And that's on every vertex of your parabola. And that's really helpful because if you're looking for the coordinate point of your vertex, once you have the x value, you can use your function, substitute it in, and solve for the y value. One other thing that's interesting is that the y-intercept on a parabola is represented by the value c in your equation. This c right there. Right? So wherever the parabola crosses the y-axis, we actually have a c value. So let's say, for example, my y-axis was here, where my parabola crosses the y-axis. This point, the y value is c. So my coordinate would be x, comma, c. And you could always solve for what that x value would be. Okay? Couple of unique things that go with the quadratic function. The function itself has a lot of information for us, so as long as we have the actual equation, we can do a lot of work with regards to finding the vertex, finding the y-intercept, knowing which direction the parabola goes to, and this is how we're going to do a lot of graphing. Your daily homework quiz is up to you. This is your responsibility. I will not be assisting you, but what you do need to do is to graph y equals negative 2/3 x squared plus 6. Compare it with the graph of y equals x squared, similar to what we did in problems 1 and 2. Also graph the equation y equals x squared minus 2x minus 3.